Welcome to Scott++. I try to approach this by making content that I would want to watch, content that I find valuable. So I use my projects as a jumping off point to talk about topics like logging or testing more generally, so it has kind of broader applications. But as a cost of that, I've been feeling recently like I haven't been making enough progress on the STAR Voting project. I just haven't been writing code. So tonight I wanted to put my war paint on and throw myself into the battle. So that's what this video is going to be, just getting back to my roots of writing some code, filming the process as I stumble through everything. So hold on to your butts and let's hit it right after the intro. Gotta start out by creating a new branch before we screw everything up. So the first thing I want to do is set up this pgboss GitHub package. This basically uses Postgres database as a job queue, or in our case, an event queue. And it looks like it's going to do what we need it to do. We've got very recent commits. We've got a bunch of stars. So it looks good. So I'm just going to install this and check that it does what we need. And then there. Alright, so that was relatively easy. I just copied the basic initialization code from pgboss. Here we give it the string to connect to the Postgres database. We spin up an instance. Then it is on queuing a job. And the job here just basically outputs to the console the job ID and the data. And we see here after doing an npm start, I added some extra console logging just to make sure I saw it and it wasn't lost in all of this. But it does, we call it the init. It creates a job in a queue, some queue. We'll look into more detail how to specify that maybe. And then we see that there is a job with some, it looks like a UUID, and it's got a data. So excellent. So now that this is working, what I want to do is abstract this, because I do want to make sure, obviously this relies on the full database running. And I want to make sure as we start building out our logic to rely on this, that it is testable. So we need also a test version of this, or something that is mocked, so that we can continue to test and validate our logic. So that's what I'm going to work on next. Okay, so what I've done now, I put together this iEventQueue interface, and it's got two methods, publish and subscribe. So subscribe, probably put that first. Subscribe will happen first when we're basically registering a handler to the event queue, saying anytime a new job comes in, this is the function, here's the handler that should be called to handle that. And then publish effectively just publishes a new message or event. Then in the pgboss event queue, this is basically just a wrapper to wrap the pgboss with this new interface inside of init. So this is interesting because generally constructors in JavaScript are not async, but this we actually need it to be async. So I put it in an init function, which returns a promise of the object. So if you just call a new pgboss event queue, it's going to be basically useless until you call init. Theoretically, I could put some console logs in here that if init has not been called, when you try to publish or subscribe, it can show you a warning saying, hey, you forgot to do this. Anyway, init effectively just sets up the new pgboss instance, which itself is async, which is why this whole thing needs to be async. Publish, again, it just wraps the boss.send, and subscribe wraps boss.work. But we do now have a little bit of typing, which is great. So here I added to the service locator an event queue method. That's again, because this whole thing is async, and return a promise that gives you all this. If we do eventually move the service locator, either as a singleton or whatever, we may want to have an init function in the service locator that basically sets up all the services that it's containing in an asynchronous way, so that then every call after that we know can be synchronous. That'll make it a little more performant in the event queue, instead of requiring a promise and then getting the value of the resolved promise to get the queue. Everything that's requesting that can just access the queue directly if the service locator itself is initting and taking care of that before anything else spins up. Then I just added at the end of the make app function this little test that's just going to run automatically. It's going to call the event queue from the service locator, subscribe this handler, and push or publish a job. So I'm just going to run that now just to double check that setting this up and basically my wrapper works as expected. So npm start, cross your fingers. So that did not work. I do not see the logs that I expected with these jobs. So let's dig a little further into this. Okay, now it's working. I forgot to await the init inside of the service locator. Common mistake. So now we've got this job coming, my param, huzzah, it's working. So good on that. So we've got our event queue using Postgres. We've got an abstraction around it. One thing I need to do now is write a mock implementation of this so that we can continue to write tests. They're going to run in a separate environment without a database. And I also want to test, and I'll set this up probably before I do any of that. I also want to test that I can publish jobs, kill the server, and then when I spin the server back up, it's going to finish those jobs, because that's the whole point of this, right? That the jobs are stored in the database. So even if the server goes down before it has a chance to process them, when it spins back up, it's going to complete those jobs. Probably how I'm going to do that, I'm just going to extend this job handler to add a sleep so that it just waits during the process, and then I'll manually kill the server after I start it, and then see how we go from there. So real quick, I just added basically a sleep or a timeout to these jobs. So basically this job is going to first print out that it's starting with the job ID, then it's going to wait for 10 seconds and then say that it's finished. And I also added when after the server spins up, it's going to publish 2 of these jobs. The first one, huzzah 1, then it's going to wait for 2 seconds and then start another one. So first I'm going to test just that this works with the promise. So let's go ahead and do that. So here I expect to see basically job 1 is starting, job 2 is starting, then eventually job 1 ends and job 2 ends. Okay, that is interesting. They actually went synchronously. So when job 1 started, it waited until it ended, and you can tell by the job ID here is the same before the second job started. So it's probably a configuration of the queue. I only registered 1 worker, so probably only 1 worker is pulling things off at a time. It's waiting for that to finish before kicking it in or before starting the next job. So now what I'm going to do is I'm going to run it again. I'm going to wait until the first job starts. Then I'm going to kill the server. So then what's going to happen, what I expect or hope, is that I still have 2 jobs in the queue saved to the database. So then when I start the server again, what's going to happen is still going to register 2 more jobs. So then I would expect 4 jobs in the queue. So I expect 4 jobs to eventually come through. So let's see if that works. So I'm starting the server. I'm going to wait for the first job to say it's starting. Great starting job. Killing the server. Okay. So here we started the first job. Maybe I probably should have added some logging that I was in queuing the job, but it's fine. Now I am going to start the server again, and hopefully we'll get 4 jobs coming out of this. Here's one. And of course, this is going to take a full 40 seconds with the timeouts I put, but fine. So it finished 1, starting 2. I also want to check that this job ID. So the first one that it started before I killed it had this ID. Let's see, it's 6C47. That should be the first one starting here. It is not. So here I only got 3 jobs out of this. The first job that was started, so this job did not complete. So theoretically it never returned its acknowledgement to the queue, but it was not called again. Gonna have to dig into that. Okay, I've added some very hacky debugging that after a job finishes, it's gonna wait a second and then print out this debug info. And so we see here after the last run, it has these are the different jobs in the various states. So it has 0 active, 0 in retry, 20 completed, 1 expired, which I'm not sure what that is, none failed, none canceled. So what I'm going to do now is I will again start it and kill the server before it finishes the job and see, once I start it again, what this info looks like. Do any of these numbers change? And that might give me an idea where or what happens to that job that was started but not finished. All right, so here it has 1 created and 1 active. And that seems to be the difference. At the end of the previous run, or rather at the beginning, it just had 20 completed, this 1 mystery expired. That's it, so 21 total, right? So then theoretically, 2 jobs were pushed in, and maybe I should add some logging each time a job is pushed in to see which state it goes into. But 2 jobs were pushed in, so I expect next time the total to be 23 at the start, and it is. So we have 1 that was active, 1 that is in state created, which is maybe pending, effectively. But then at the end, and so we have total 23. Here we have a total 25. All right, let's add some more logging and dig deeper. Right, so right after publishing a job, it goes into created before it started. Then 2 are active. Is it ever going to decide that this active one, it needs to do something else with this active job? Okay, based on this, it's telling me that it seems like it's keeping these jobs, the jobs that are started but not finished before the server dies, is keeping them as active, which means based on this chart, the only place they're going to go is eventually to expired. And they're not going to go to failed, and they're not going to be retried. They're only then going to be archived. So that is a bother. Let me dig deeper still. Wait, is this doing stuff now? Or am I just scrolling up and down? Ooh. Okay, it looks like it eventually grabbed these jobs. So I'm going to look at what the default retry time is. It might be that it's just very large. So the default expiration is 15 minutes. So basically all these jobs that I killed and then it didn't pick up, it did pick them up again after 15 minutes. But I want to find a way so that once the server starts up, it automatically goes and looks for all the jobs that are in that active state, but obviously are not processing anymore, and retries them, right? So we maintain this kind of first in, first out-ish property. story short and to condense the last 2 hours of my life into a few minutes. The PG Boss is basically working, but once a job has been started, it's moved into the active state. And if the server dies while that's the case, when the server starts up again, it does not automatically retry those jobs. And it gives me, there's no API to access them. I can access jobs that are in the queue, and I can access jobs that are completed, but there's no method to get jobs that are theoretically active. If there was, I could theoretically manually fail those on once the server starts up so that they're then retried. As is, the options would be to, one, set the timeout for a job to be low, so that way if the server does die, by the time it starts up again, it will consider those jobs timed out and will retry them anyway. Two, one of the benefits of PG Boss is that it does expose the Postgres table, so we could just write some SQL statements, go in there, grab the active jobs and fail them manually. Or three, I can submit a pull request to PG Boss to try to add this feature. But for now, I think we're okay with how it works. I'll just set the timeout to be lower. And then we can go ahead and write a mock implementation to make sure that everything works in our test, and then start rolling this out into some of the controllers that require this functionality. And then in the background, theoretically, I can submit a pull request to PG Boss. But none of that is going to be tonight. I think I am going to turn it in. I'm very glad that I was able to tackle this tonight. I'm feeling more like myself. So that is awesome. Thank you for going with me on this journey. And I think I'll do more tomorrow night. So I will see you in the next shot. All right, welcome back. Previously, we were working on getting our event queue set up for the STAR Voting project. We're using the PG Boss job queue, and then we have also abstracted that with our iEvent queue interface. So the next steps, we need to change the expiration time of the jobs that we're putting in, and then we need to go ahead and create effectively a mock of the event queue so that when we're doing all the testing, we can test things without a database set up. Now, one thing I've been thinking about is at what level to do the abstraction of the mock event queue. PG Boss obviously has a lot of options for configuration in terms of retry times, timeouts, how many workers you have, etc. So I'm wondering if it makes sense, do we want to build all of those options in to the mock, or do we just want to say that all those mocks are part of the implementation details of our event queue abstraction layer, and so for the test version we can just assume some defaults and we don't need to provide all those options. That's probably the way I want to lean if we get to the point where we start needing different jobs or processes within the STAR voting system to use these options of PG Boss, different jobs with different retry times or different expiration. Then we might start adding those to the abstraction. But for now, I think we're going to keep the interface for the test event queue very simple, just publish, subscribe, etc. And then in the background, we'll make sure that the handlers are called. So without further ado, okay, first thing first, I went ahead and inside publish for PG Boss queue, I've added a default options for retry limit. This was from before, but now I added a default expire in 60 seconds, which should be plenty of time. Most of our events are just going to be writing to our own PG database, so it should be fine. And so now I just want to test again that this works. I went ahead and cleared all the results from the queue. So now I'm going to again kind of resume the testing I was doing the other day. I'm going to let it push 2 events into the queue, and then I'm going to kill the server and then start back up and see that those events are indeed resumed. Starting job, terminate. Okay, so here we see published 2 jobs into the queue. One of the jobs was started, and now I'm going to start the server up again. Maybe, you know, let's go ahead and wait 30 seconds so that expiry time really does pass by. Okay, starting back up, and let's see here. The first thing that happens, even before these new jobs are published, is we're starting this job again, which I hope has number 1. And then we see at the end, we have, oh, not done yet with this last job. There, we have 4 jobs completed, which is exactly what we want. So we are in business. Now, the next thing I'm gonna work on is writing that mock version of the event queue, so then we can start writing some business logic that uses it and test that business logic as we write it. So let's do that. Okay, so I threw this together pretty quickly. So it's the mock event queue. Basically, we have a map of handlers. So map from the queue name to the event handler, and that's set up in the subscribe method to help with debugging. If the handler is already registered, I log an error just to help whoever's having that problem. Then I keep an array of pending jobs. The job includes the queue name, the ID of the job, and the data. So then in publish, what I did is first I create this job object, which just creates a random ID for the job, similar to what pgbot seems to be doing under the hood. And then I just set all this data. I push this into the pending job queue, and then I call but not await this trigger jobs, and finally returning the ID. So trigger jobs, again, I'm not awaiting this inside of publish. Publish will return even before the job finishes triggering. If we're already working, then skip. Also, I added an option to pause the queue. And so if this is paused, we again skip. If none of those are the case, then we're going to mark ourselves as working. We're gonna pause for a second because I do want to imitate the type of delays that might be faced in a production scenario. I don't want these to be picked up immediately, even though they could be. So I want to put a little bit of a break here. This delay is configured up top right now. It's just 1 second. And then we're going to move on to process the job. In processing the job, we just grab the first element of the pending job array. If the array is empty, let's not forget to say we're no longer working. We're going to try to do the job and log an exception if that doesn't work out. And then we're going to, again, mark ourselves as basically available for work and call trigger jobs again, which repeats the cycle. Do job just grabs the handler. If there's no handler found for whatever reason, again, just throw an error to help whoever is having that issue, and then go ahead and await the job. Finally, some methods just to help with debugging. We've got pause, resume, resume after we say we're no longer paused, do recall to start the trigger jobs again to resume that cycle. Clear storage just deletes everything, and debug info just prints everything to console. One thing I still haven't figured out how I want to handle is this is not using the logging library. Theoretically, we would want to pull in a logging context and use that, but also similar to previously when we set up each of the requests to have a request ID, I imagine that's some info we would want to capture in all these jobs coming in, right? We want to have insight into, for each job that's coming in, what is the request ID that kind of generated that job. Theoretically, we can say that's not really the job of the queue, and if we want to put that data into the data object itself, we can. That may be the way to go, but I am thinking about, do we want to maybe extend these publish methods for the event queue interface to ensure that that data is passed down? Something I'm still thinking about, but for now, in the app, again, this is the test that just runs automatically whenever the server is started. Obviously, it's not something that I want to commit. I just replaced the event queue that we were getting from the service locator with the new mock event queue. And then I saw that indeed everything we would expect to happen is still happening. When the server starts up, we're publishing 2 jobs. We're logging out the state of the, in this case, the mock queue. We're publishing another job. Eventually, the first job is started, then finished. Then the next job is indeed started and finished, as we would expect. So everything there seems to be working. Big success on the mock event queue, or at least getting that spun out relatively painlessly. So pretty short session tonight, but I think that takes us to a good stopping point. And I know in the back of my mind, this video is probably already like 20 minutes long. Now that we have both an implementation of an event queue as well as a mock event queue, we start to go ahead and integrate this into some of the logic. So the first candidate for all of this is going to be the cast vote request. In that, we're trying to do a few things: save the user's vote, mark that the user has voted, and send an email. And we want to make sure we do all of those atomically. So probably in the next video, later this week, I'll dive into that and start utilizing this event queue to take care of all those. But that will have to be for another night and another video. I'll probably do some code cleanup, but nobody wants to watch me do that. For now, the end. Mixolate.